Welcome to today's webinar. My name is Liz Stokes and I'm from the ARDC, and I am excited to introduce you to this fascinating topic we have: skills, catalytic converters, the road ahead after training. I would like to start by acknowledging the traditional custodians of the land and knowledge that we have here in Sydney. That's the Gadigal people of the Eora Nation. Aboriginal sovereignty has not been ceded in this country. I pay respect to elders past and present, and acknowledge that looking after country has a lot to do with curating knowledge of that land, which ties in with what we are here to talk about today. Now, I've got a little bit of Zoom business to run you through first, which is that we are recording this session and we'll upload that later to YouTube. You're encouraged to turn on your video and use Zoom reactions as well. You can ask questions by posting them in the Zoom chat, and please do that. I encourage a lively back channel amongst the Zoom. Okay, we also have a code of conduct for our activities, so please follow that if you feel you have any reason for concern. So let me start with a bit about this forum series to set the stage. The purpose of these webinars are to facilitate knowledge exchange across the trainer community in Australia and showcase digital research skills development activities, resources, and best practice across the sector. So this place is an opportunity for trainers to reflect on your own practice, to see good and interesting initiatives, and also to make connections with peers across a national network of trainers. So, to the topic at hand. You may be wondering why we're using a fossil fuel burning metaphor. Well, just like a catalytic converter reduces the harmful emissions from a vehicle's exhaust, we're exploring how certain catalysts can help researchers apply new skills to real-world research. I personally love a literal metaphor. What catalyzes that enthusiasm and new ideas that we have into changed behavior? As trainers, you play a crucial role in introducing cutting-edge technology, like software development, to a novice audience. Your ability to make complex ideas accessible and engaging can drive meaningful progress in our research community. Next slide, please. Thanks, Alan. We've brought together 4 esteemed speakers to talk about this topic today. After I introduce each one, our speakers will provide a short lightning talk on a chosen catalytic converter. After these lightning talks, I'll kick off with a few questions for our panel, and then we'll move into some of those questions that you asked at registration and field any other questions from the live forum. So we will expect to finish up within the hour. Okay. Our first invited guest is Rowland Mosbergen from the Walter and Eliza Hall Institute, or WEHI. Rowland has taught coding to biologists as part of their PhD and currently runs a student internship program teaching bachelor and master's students about research software engineering and open science. He teaches that coding and technical skills is only 5 to 10% of what is needed to be successful in a collaborative environment. His starting prompt is: how does the WEHI student internship program help students to make good on turning new skills into practice?
I get a lot of very enthusiastic students wanting to get real world experience. And the biggest thing I have to do is to unlearn the myth that coding is the most important thing. Usually I'm working with data science or software engineering or sort of technical things. And really, if you look on I don't know if you can see the column on the left talks about how a student's view of how to tackle a complex project. But I think a lot of it is implementation and coding, and you don't really need to know about the high level client needs or the high level technical architecture of how everything fits together. But the way I try to explain it to them, which they don't actually pick up on most of the time, is how can you drive a car efficiently when you don't know where you're driving to? And if you emphasize car as the technical skills, you can't apply your technical skills if you don't know where you're going. So I try to provide this idea of how do we focus on clarity of high-level client needs, high-level technical architecture, how do things fit in? And the implementation and coding is sort of left to last. If you have a look at the next slide, when we actually start talking about that implementation level, students assume again that writing code takes the longest amount of time. But if anyone's ever had to try and troubleshoot someone else's code and test someone else's code, you know that troubleshooting something is actually really, really difficult the more complex it gets. So when a student thinks about it, they think I'm going to spend a lot of time doing coding. When I do code, I realized this in the last intake. I realized, hey, I don't want to spend a lot of time. I'm going to make a small change and then I'm going to test and troubleshoot it because I want to minimize my time with troubleshooting because I know that takes the most amount of time. So these are the two main myths that we try to uncover as we do that. And sometimes, I would say 90% of the time, the students have to learn it by themselves. They have to make the mistakes because they don't want to learn from my past mistakes. They have to sort of learn it from their own mistakes. So that's it from me.
Thanks, Rowland. Okay, I'm excited to introduce Amy Cotton, who is a senior learning designer in the Graduate Research School at the University of Technology, Sydney. Amy has led the development of development programs across a number of education sector settings and usually works with groups of learners between 2,000 and 115,000 in number. Finding the ways to help individuals find and use their new learnings is a daily challenge, and Amy is always searching for new ways to make that happen. So the starting prompt we gave Amy was, from a programmatic perspective, what evidence can you gather of HDR students putting their skills into practice? So let me know when you're ready to go.
I'm ready to go. Thanks, Liz. Beautiful introduction. All right. So my work at UTS, working within the Graduate Research School, is really to look at the whole program and to work out what we can do en masse, but also try and help individuals along with their learning. To that, the question of what evidence can we gather? Well, there's two types of evidence really for me. We can get the data of what people attended. So what's on this screen is how we go about doing that. Our research falls into 5 main categories, which are around the graphic on the right-hand side: research knowledge and skills, research communication. They go around. None of them have priority over each other. The only priority that we have is student wellbeing. And then we have the other 5 categories in there. So we tag all of our learning opportunities against those, and then we put this into a booking systems that we call Research Futures. Through that learning management system, the HER students can record their activities, but they can also then self-record other activities that they're doing. So we know what they've booked into in terms of our formal training courses that are happening. But they're also listing things. I read this, I went to this network meeting, I went to this professional association event, whatever they want to put in, and they're tagging it against these 5 categories. And this helps us know what they're interested in, what they're actually doing, and sometimes it tells us how they're applying their learning. So they may have gone to a similar sort of session of training and then applied it in some other activity, such as a networking event. Could we go to the next slide, please? That's the data end of it. That's always sort of a little bit limited by what people actually choose to do when they self-record, because a lot of people, of course, just don't. They're too busy. We have some very diligent people who do it. So we're also looking beyond recording attendance or beyond recording what those self-directed activities are. We're keen to ascertain whether they've actually applied their learning to their practice. Now, this slide just looks like a slightly old one, so I might just talk around it a little bit. But we're redesigning our whole program so that it's structured in a multi-week or multi-month learning situation. So people have the time to come and learn a couple of skills, go away and apply them, and then bring them back a couple of weeks later and say, well, this is what I did with it. can I get a sense check of, am I on the right path? They get a little bit more learning, they go away, apply it again and come back. So they're in a cycle of hearing new concepts as well as applying them at the same time. When the whole experience formally ends, we then email a sampling of students to ask them for feedback and an example of how they use that in the learning. We surprisingly get quite a lot of information back this way. We email them individually and they tell us individually what they're doing. Then what we do is alongside that, we organise drop-in sessions, which isn't on this slide, but drop-in sessions for the practical application questions, troubleshooting checks. That's my round off music. The last thing we do is we organise follow-up events where they showcase how they applied it, and then we'll promote it in social media in some way.
Thank you, Amy. It's so fascinating to see that. Next up, we have Craig Windell who's an eResearch analyst from QCIF in Queensland. And Craig has been working in the IT field for many years, from desktop support, systems admin to team leader roles. Craig is now focused on supporting researchers who are using technology. Craig helps people one-to-one in small groups and large training activities. The starting prompt I gave to Craig was, from a trainer's perspective, as an embedded practitioner, QCIF serves a number of research organisations. What do you observe from this practice? So, take it away, Craig.
Thank you, Liz. Yes, what do I observe? As ERAs, there's a number of us. We're a diverse group of people. We all have different backgrounds and so forth. So yes, coming together as a common theme is always challenging. But breaking that down into these major categories, the individual help to researchers, instructor-led training courses, and Hacky Hour is sort of the journey that we look at. Jumping into the Zoom world, the best way we find for training is to get lots of interaction, and that's a real challenge over the Zoom world because number one is it's hard to see when you're a trainer delivering material whether you're getting that impact, whether people are following along and so forth. So yes, you have to use the tools within Zoom that some people are comfortable with, and some people take a bit more encouragement. And the method we use for most of our training is to have lots of practical exercises for people to do. We use software Carpentry for many of our courses, and we find they're very good from an exercise perspective. And the other thing that we do a lot in our training courses is to bring lots of real world experience in, and certainly the trainers have their own story to bring in with that, and they're mostly very happy to sort of share their fun experience with the topic and so forth, all with the topic of, all with the idea of trying to get engagement and that enthusiasm. And I don't know if we can claim that we're really good at it, but I do like to say we get lots of good feedback when we at the end of our courses. That follows on to the sort of the next level or where you go after that. We all have hacky hours where people can come along and ask the experts or the helpers the various questions. And that's a good sort of feedback mechanism of seeing if what training we're doing, whether it's hitting the mark or whether we need to schedule other exercises. And moving on to after the hacky hour and the individual help is yes, if I'm contacted by a researcher that wants help with something, I'll try and do what I can to do that, and that's always the approach of enthusiasm to help people to get enthralled with the topic, and some of the topics are pretty dry. Thanks, Liz.
Great. Thanks so much, Craig. And following up, we will have Magda Guglielmo. I'm pleased to introduce Magda Guglielmo from CSIRO. Magda started her journey with a PhD in astronomy and coordinating a computational physics course, but soon found herself building soil moisture models and guiding researchers in computational science. Now a research computing specialist at CSIRO, she helps scientists apply computational techniques to complex data problems. Passionate about teaching, Magda recently completed the Carpentries Instructor training program to sharpen her approach. And the starting prompt we gave Magda was, as a scientist and peer educator, what are some of the opportunities and challenges of in-house skills training programs?
Okay, thank you, Liz. So in CSIRO, I helped with a particular program that was called Data School. And the idea was to train scientists or young scientists to sharpen their skill in coding. And the program was run in-house. So we had expert teaching a particular aspect of coding to scientists with little or no experience in coding. And what you see in this slide is what I think are the opportunity for running this kind of program. The first one, of course, you can personalize your learning. You know the people, you know what they need, and you can focus the teaching towards they need. It's also helped to create a community, because at the end you find out through this program that there are other people in the same situation, so they can come together, ask questions together and help to solve their problem. There is also the advantage of having expert as a trainer, meaning that they know what the problem are and they already find a solution. Of course, all of them, they come with challenge, because when you have multiple people coming from different background as researcher in CSIRO, you have skill variability. Some of them might be very good in data analysis, for example, but not in modeling. Someone has experience in Python, not in R. So you have different challenge in set up the resources. Can you move to the next slide, please? So, but in general, the most important thing that I think in-house skill can help is fill the gap between generalized training and what the people really need. Next slide, please. The reason why is because what we identify from talking with the student is that when they do a generalized course online, they always find it's too easy. So they can follow the tutorial, they can understand what's going on, but when they come to their own problem, there's something missing and they cannot understand what is the problem. So what I think is the cause is that generally tutorial online, they have a very linear structure. Either they want to talk about the data or they want to talk about the code, but everything is designed to work smoothly. When you go to reality, the problem is a little bit more complicated than that, because your data need cleaning, your code need debug, then you need to come back to the cleaning of the data, and then you need to fix the data code. And this is very complicated if you're not an expert or a coder. So you get lost and you think that the skills that you learn are basically unuseful. What we did in Data School, we split the problem, trying to make it as close to reality as possible. So what we did was to run a cleaning data session, in a sense where we wanted to make a machine learning model, but we show all the possible complications that you can have when your data are not good. Then the next day we changed the data set. We asked them to repeat the cleaning that we applied the day before, what kind of question they have to ask. If there was a technical problem, we can help with the code, but we wanted to teach them the question they have to ask to the data before running the model. And it was surprising to realize that people don't think that the data in this kind of problem is the most important thing. So you will spend probably the 80% of your time cleaning the data rather than writing the code. And it was nice to have this discussion with the student, let them think about what kind of problem they can face. Next slide. But of course, all of this has the problem that when you organize in-house, you need to think about the material that you want to present. And when you prepare your material and all this kind of question and how you drive the discussion, you have to put in there a lot of problem, like as I mentioned before, different background, different skills, different time availability. And then, of course, the trainer, the expert as a trainer, they're not necessarily a good instructor. Be an expert doesn't mean that you're good in teaching. So you have this problem to discuss to balance between the thing. And I was happy to see that Craig used the carpentry because through data school, I come closer to this organization, and that took a lot. I suggest you to have a look at the material that they offer because they are very good, especially because you have a community support. So you have an idea of what worked and what didn't for others, and you can adjust for your training. Thank you.
Wonderful. Thank you, Magda. Let's come back to our gallery. And we can probably stop sharing screen now, Ellen. Thank you. So what an amazing breadth of knowledge and experience we have amongst our panel. Thank you very much for your presentations. What I'd like to do is dive right in. I have a question that perhaps relates a bit, perhaps extends to Rowland's question for Magda on scaling the personalized learning, individual learning plan. What I want to ask first is, usually our audience today are united in a quest to maximize the impact of the training they deliver. So what can trainers do to enhance the effectiveness of the training they run? What kind of things are in their locus of control? I might start off with you first, Magda.
I think that it's important to focus on what they really want to do, in the sense that what I collected for, sometimes I ask people, what kind of training do you want? Do you want to see? And they ask specific questions, like I want to do some image classification, for example, because I did this tutorial and it didn't quite work. The problem is that to make it as close as possible to reality, there are a lot of data sets for this kind of problem, for example, the cats and dog. Now, I love animal, and yes, cats and dog are a good example for image classification, but it's not what they do every day. The data they have the image they have, they are not be enough for what they wanted to do. So they have to think about how to make it better, how to collect more data or extended data set. But this is not what is not easy, because you need to find this data set that work for everybody. They kind of explain everything, but at the same time, you want them to practice hands-on. Like, this is the question that you want to ask from the data set, and you guide them while they're doing it. I don't know if it makes sense.
Yeah, it's a complex area, isn't it?
Yeah.
I know from the instructor training in Carpentries, one of the things we teach is how to take stuff off your plate, like out of your agenda for teaching people. Yeah. Craig, any others who would like to weigh in on that question?
Yes, I guess I'll just reinforce the idea of the practical nature of doing things. When you're like in a one-to-one situation, it can be very easy to quickly watch what someone's doing and whether they're doing the right thing, and scaling that up to a classroom size training session is that big gap. But of course, the resources required for individual sessions is way more than what we can all afford. So yes, having that the lots of exercises for people to do, lots of practical things for people to do, I think is really helpful in that regard. And having that feedback channel to with limited interaction, of course, is ask people to show what they've done. Whether that we generally get some people that are willing to do that, but not many people do. So yeah, it's finding that balance is an interesting challenge.
Yeah, you're right. Okay, let's go. I think I was ambitious thinking that would turn into a discussion about scale. So how would that who would like to respond to that question about handling individual things at scale? Amy?
I could try to answer because at scale is how do we deliver an effective training program that is meeting someone's point of need when they need the training and also delivering to several thousand people simultaneously? It is a difficult question. And what we try to do is we try to follow universal design for learning, the guidelines there of like multiple means of engagement, multiple means of representation, and multiple means of action expression. And what that means is that we will have the training there, but it'll be there basically 3 times. We have it in Canvas in a static module that people can just do it anytime they want, which is a very interactive thing, but still is just available 24/7. Because I'm also trying to deal with training students who aren't in Australia, so their time zone may be in Africa or South America. So I've got to have things available for them at all times, but then also live workshops. And then is there opportunity for other sorts of ways that they can contact presenters or trainers and get more feedback about their work? So when I'm scaling, whenever we come up with a new idea, I'm already trying to build for how can we meet the masses and have something that's always there, and then how can we individualize it with workshops? And we just try to run them as often as we can.
Yeah. Rowland, I see you have a schematic in the chat there.
Yeah, this was just about a thing that I've noticed. I don't know if you can show it up on the screen, but we tend to focus on the first row, which is the technical side. And we tend to focus on that introduction class size, the 1 to 20. And I think Magda actually mentioned in her things about, being able to use your own domain data and personalize things for very specific things like imaging. And that's that sort of middle right here. But once you get past that level, the thing that I really liked from what Craig and Amy were mentioning too was this idea that you have to sort of reach out to people to overcome really specific problems, and that's where the drop-in sessions are so valuable. But the thing that I keep missing, I keep not seeing, is having senior postdocs and group leaders in the leadership positions understanding what you need to build a team, or to understand how long something might take. And I think that's where there's a lot of opportunity in the training side. So I'll give you an example, concrete example. I was talking to someone who's a research software engineer, and they always struggle to convince their supervisor that this piece of work will take this much time, because that person is not a computational biologist. And so they have no real benchmark to know whether their postdoc is doing well or not, or if they need skills or not. And there's a gap there from what I've seen. And so I don't think it answers the scaling problem exactly, but I think you want to make sure you're strategically deciding, okay, we're going to ignore that bottom row. We're fine ignoring that bottom row, but at least you're intentional about it. Because I think that actually is something that could help out a lot of PhD students who are struggling if their supervisors haven't gone through the same struggles. They could understand that it's not as easy as saying, okay, that'll take 2 days, when it might actually take 2 weeks for a professional.
Great answer. Okay. I'm going to take a little bit of a turn now. Sometimes we arrive at solutions not by dividing that silver bullet, but by simply dodging the worst case scenario. So to follow that trajectory, I'd like to ask the panel, what is a common misconception that you encounter when it comes to applying skills learned after researcher training? Yeah. Who would like to start that one?
I can have a go at that. I guess from my perspective, a misconception is training has all the answers. It's only the start. The best I usually hope for out of delivering a training session is to get people interested in the topic, and then they can run with it themselves. The idea of delivering material is really good if you've got everyone traveling at the same pace and coming from a similar background. But yes, once you're working with a diverse group of people, it becomes a real challenge. And yeah, the biggest hope I have is to get people interested in the topic so they can run with it, because yeah, the training is not the be all and end all.
So true. Yeah. Rowland, I think you had an answer ready.
I was just going to repeat what I was saying before. A lot of students struggle when they're thrown into something complicated, more complicated than they're normally used to, because they don't know how to use those skills. And it's really actually going back to the scaling problem. One of the things that we did just recently was, you know, we were trying to say, hey, here's all the students. Here's all their names. We've got permission to share their names in a spreadsheet. Please fill out some of the skills you'd be willing to share with other students if they came to you. And that was actually quite nice, because it gave me a bit of an understanding of what people were confident in and or not. And just tying back into what Craig was saying as well, there's a lot of imposter syndrome. I don't know where it's coming from, but there's this education thing that's happening somewhere along the lines where it's like, if you're not good at something, then you're not good at something. And it's like, that's the end of it. And it's just like, oh, you know, it's too hard. I need to be able to do that. I'm not ready for it. Sometimes there's a psychological block to people going through and doing these things. And it's something that I see, especially in the students, once they start being in this collaborative environment where everyone's encouraged to ask questions, because that's how you learn faster. And I actually had another slide for that, but I didn't think I could fit it in, where you've got a senior person asking lots of questions at the start and asking very few questions later, and a student not asking many questions at the start and then struggling later on.
Oh, that's really prescient. Yeah. Thank you.
I agree with Ron about the imposter syndrome. I think that especially I see in coding, because we are not, CSIRO is not a software company. We are scientists that develop code. And there are people who are scared of actually, like, I'm not really a coder. I don't know how to do this. I don't really understand that. It's too complicated. I'm not a software engineer. And what I often share with them is that I am not a software engineer either. I never have a proper software engineer training in my life. I was them. I was a scientist. They have to write a lot of code, and if I can, you can. Basically, this was the approach that I often use. And sometimes I tend to destroy what they think is scary. Like everything, like testing. Rowland talk about testing. Oh no, I'm not doing testing. I'm the software engineer. You do that. And then the difficulties is to explain them. You want to do testing because you want to make your life easier, not because you are a software engineer. Because you know that if you fix the problem now, you don't have to deal with this later. And sometimes you just need to change this attitude of, it's too complicated for me. I do science, not computer science. And you have to use a little bit of technique in computer science to make your life easier. And sometimes it's hard to tell them, to pass this information to them. At least this is my experience.
Yeah, that's so true. Amy, you've got a thing to round us out for that question.
On a misconception, I think I'm going to think about this from a programmatic point of view, so a slightly different angle from everybody else. But I get pressure from leadership management to produce stats on, has the training been effective? And the thing I know is that sometimes it may take 2-3 years to see whether that training was effective. But people don't have the patience to find out that data a little bit later on. So because we can provide training and it may not be at their point of need, they come to it knowing they'll need it in 6 months, but by then we've already collected our data and it's been wrapped up with a bow and presented upwards. So I think that's something I'm constantly struggling with, is that there's an idea that effective training has to be effective immediately, and it's not something that you might be storing up for future times.
Oh, that's great. And in fact, that starts to move into the last question I wanted to give everyone, which was, usually in this kind of Q&A role, we ask you the questions and then you answer. But I would like to give our panel the opportunity to ask our audience questions here. So, in the style of the Carpentries, what questions do you have? What would you like to provoke amongst our trainers' thoughts, our community today?
Well, I guess I can start with that. With how do you balance the people who are having real trouble getting through your material with the people who fly through it and get bored really quickly? How do you tailor your programs to capture everyone?
Oh, that's a good one. Okay, answers in the chat, please. Amy, have you got a question?
Oh, my question would be, well, I'm always curious about what is the deciding factor for when people choose to commit to professional development or not. So what gets them in the door and what makes them commit?
Oh, another good one. Yeah. Magda?
My question would be about how do you design your training for what they want or what you think they want? Meaning that is sometimes the problem are hidden because they think that the problem can be, again, data science, cleaning data, but actually the problem is the code part of it, or the other way around. So what do? You do offer them what they want or what you think they need?
Oh, really good questions. Okay, and Rowland.
I'm going to ask a controversial question, but I'll skip that one. I'll ask a community building question. What's stopping us from building a more coordinated sort of hacky hour drop-in session nationally? What's stopping us?
That's a good question. I can hear the ARDC. Can you answer that? Silently.
No, actually, I'd actually get them to answer that last. I don't want to ask everyone else, like, especially when I can't help but shake the feeling that we're duplicating tutorials and we're duplicating knowledge. We're doing it individually. And I thought the drop-in sessions might be an easier way to connect.
Yeah. Oh, okay. Community, I would love to hear your thoughts on that. Okay. All right. I'm a kind facilitator, so I'm going to give people time to think about those questions and respond in the chat, or raise your hand if you desire. Meanwhile, I'm going to turn to our list of questions that registrants have been so kind to share with our presenters beforehand. I'm going to start off with this one question to Rowland, back to you actually. Are we really teaching people what they need to know? It does come back to, so Magda, I think that you mentioned this just then. What responses do you have? I'll go Rowland first.
Yeah, the thing that I teach that I think is 1/3 important is technical skills, 1/3 importance is domain skills, 1/3 importance is continuous improvement skills. And I don't think we try to focus on continuous improvement skills at all. So the 6 continuous improvement skills that I look for is tolerance for complexity, tolerance for ambiguity, critical thinking, learnability, adaptability, and being collaborative by default. So these are the things that I'm trying to basically test the students for in a safe environment in the internship.
Yeah. Sounds very sensible, but obviously you need a structured internship to be able to, you know, promulgate those.
I don't know how to actually teach it. It's more like they find it out for themselves.
Yes, and you've got the, okay, yes, today Joe has worked out on critical thinking. Right. Magda.
My philosophy is that there is no one way of doing stuff. So you have to be, what I'm trying to teach them is that you do the first trial. It works, good, now improve it. If it didn't work, let's talk together why it's not important, why it didn't work. I don't want to give them the solution, even if sometimes the solution is obvious for me. I want them to find the solution. And while guiding them, I give them what I call good practice in coding, in software engineering. I don't like the expression best practice because what's best for me might not be the best for you. So I have the define what I think good practice, the minimum set of good practice scientists need, and I'm trying to pass them. So it's not only the code itself, but also small little things that can help them in future. And I want them to, by asking questions directly to them, guiding them towards the answer. And I feel kind of clear. Like I want them to work out the best solution for them. There doesn't really need to be the best solution for everybody. You just need to work for them. And then they have to accept the idea that later they can improve their code. They can improve their skill because it's not done. You're not going to write your code, the perfect code in one trial. You need to come back to it and you need to prepare for it.
Yeah. I think that this links in with another question about when you're thinking about what role does participation in open source projects play in ongoing skills development? I think we're getting there towards realizing that the problem is not simply the application of the coding skill or knowing how to code, but it's all the things around developing that. Does anyone have any further comment to make on that participation in open source projects?
I think that open source projects give a very good chance to really challenge yourself. And by doing that, you learn a lot because you push your limits and you can, because it's not only for you. Open source means not only for me. My code is not going to be on my computer for me only. I need to think a lot of other things. I need to think how it fits with everybody else's view of the problem. So it's a good challenge and you create a discussion with others. You get feedback. Sometimes things don't work. So you, as Rowland said, you learn from your mistake and you keep improving. So it's a challenge, but I think it's a good challenge for level up your skills.
Yeah, thank you.
Plus, open source projects don't usually have good or up-to-date documentation. So you're having to use your critical thinking skills to try to understand how it fits in. And then you start to realize that you can only go, a few lines at a time to work out what it does, test it to be able to figure out how everything fits together. So you're forced to do it yourself. And that's the other thing that makes me wonder about teaching critical thinking. Sometimes I feel you have to be in a situation where you're forced to do it yourself and you have to move away from the hand holding. Going back to Magda's conversation about not giving them the answer.
Yeah, thank you. All right, going to move us along a little bit. with a question on how do you keep up to date on what further training your community might need? Kind of links a bit in with how, what skills do people want? I'll go to Amy first for this one.
Yeah, constant work and complicated work on this front. We do survey our participants, formally and informally, about what their points of need are and what are causing them pain points. But then at more casual networking training events, we prompt conversations to ask what they need. So I'll be working a room of maybe 150 people and just asking similar questions of everybody to find out what they're up to. But we're also talking to their supervisors, to also their industry, about what they're expecting in terms of the skill sets and capacities of their early career researchers. So some of our developments are due to data-driven data that we've collected. Sorry, bad sentence. But then we're also trying to predict burgeoning needs or new needs that are coming down the road. For instance, pivoting towards preparing people for Gen AI in research. We started with critical thinking about ethics and stuff like that, and then we moved on to actually how do we apply the actual skills of using Gen AI as a research tool later on. Yeah, but sorry, that was a very bad sentence end.
Well, it's a rich tapestry, isn't it? Right. And I think we get into the side of realizing that although we talk about skill development and this is the business of training, actually, to go back to Rowland's thing about, well, what are we even doing this for? Okay, it's about changing behavior and, about you. In order to learn how to drive a car, you kind of also need to know where you want to go in that car, right? So the point is, when we look at why people are learning these new skills, it's not to have a badge that says that you have the skill. It is to be able to apply those skills in a new context and actually to change behavior in research practices. So for behavior to change, I guess I think you need those ideas to happen more than once. So it's not simply about having the idea in the training, but you need to hear it from several other people, from people telling you in your networking sessions, as well as seeing the question come up in your own communities of practice about what is important. And once you get those ideas from several or more people, then it starts to be a community responsibility, I think. Been doing some listening to some work on social network analysis, and it's changed my perspective of how these things go. And clearly, I just have to tell everyone about it because it's such fascinating research. Anyhow, it is time to start our wrap-up process. So thank you, my fine panel, for presenting today and engaging in an incredibly interesting conversation about skills catalytic converters. Ellen, I think we might need the slides back up again so I can prompt everyone to head towards the feedback survey. Thank you. Kit has put a link down into the chat there. As many of you know, asking for feedback is a good way to gauge your learners' reflection and what they've learnt so far. So I encourage you to tell us what you really think about today's discussion. And then, I was going to hand over to Kit for our to wrap us up.
Okay, very happy to. The standard ARDC at this time of the year is, next slide, please, Ellen. International Data Week, 13th to 16th of October, just before eResearch. We've got our Skills Summit happening right smack bang in the middle. Please come and enjoy the wide range of data-y stuff. There'll be lots of skills discussion happening with a stream at eResearch, bound to be a stream at Data Week, and certainly the Skills Summit in the middle. There's a koala competition. I am just going to flick the link out into the chat along with quite a few other links. But there is a koala competition where you take a photo of the koala and you post it on social media, and then we all see how wonderful it is, and you can win registration to IDW as a result. I've got posted information about how to subscribe to our newsletter, which will have information about the upcoming National Skills Fora happening. And the next one, watch this space, is about leveraging Carpentries networks for researcher training, happening on the 26th of February at 1 p.m. Australian Eastern Daylight Time. So, as Liz said, thank you very much to the people who discussed and gave their time, and to the people who asked really good questions in the chat and turned up and made this part of the community that we're building here. So thank you very much. Cheers.